Over here, let's consider that the disk is released from rest on an inclined plane. Disk is released from rest on an inclined plane. This can be assumed to be of mass m radius r. Is released from rest on an inclined plane. The inclined angle of incline is theta. Let's assume this height is h. In the first case, there is no friction between them. There is no friction. The surface is smooth. And in the second case, we have a non-zero value of mu. The same setup, just that the mu is non-zero. Mass m radius r. Mu is non-zero. That's the only change. To find out the velocity of the center of mass, the same height. And to find out the BCM at the bottom, when the disk reaches the bottom. And find out the BCM at the bottom of the incline. 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 Assume no slip in the second case. First case? First case. First case. Tell me the motion of the disk in the first case. First, consider the case 1. Tell me the motion of the disk. Rotation plus translation. Why will it not do? Friction is not there. So, friction is not there.
There's no force, tangential force. Like the force is acting through the center of mass. No torque.
So no torque. There's no torque. The word is torque. Yes. Can you understand this? Over here, when the body is released on a smooth surface, let's try to draw the free body diagram of the disk. Someone a question. If I draw the free body diagram of the disk, how many forces are there on the disk? Normal from the surface and mg. Both these forces are passing through the center. And so I can say that there is no force which will rotate the body about the center. Yes, there is no force which will create a torque about the center. We know that if there is a point about which the body rotates, if I apply the force upwards, it is rotating clockwise. If I apply the force downwards, it is rotating anti-clockwise. If the line of force passes through the axis, there is no rotation. Similarly over here, both the forces are passing through the center of mass, so I can say that the net torque about the center of mass is 0. So the body will not be able to rotate. Yes, torque is 0, so I can say that alpha will be 0. Torque is 0, alpha will be 0. What is the initial omega? Initial angular velocity is released from rest, so omega I is 0. So I can say that if omega I is 0 and alpha is 0, omega can be written as omega I plus alpha t. Omega remains 0 throughout. Yes, so the disk just slides down. The incline, and the motion is a pure translation. Just write this down. As the friction is absent, the torque about center of mass is 0. As the friction is absent, torque about the center of mass is 0. Friction is absent, torque about the center of mass is 0. And the body just slides down the incline. The disk just slides down the incline. Yes? What is the motion? The motion is a pure translation. And so what can you say about the velocity of the center of mass at the
2gh.
lowest point? Obviously it will be root 2gh. Can you understand this? The center of mass, let's assume that the velocity is v. What is the velocity of the topmost point? Velocity of the topmost point. The entire thing is under translation. So all the points on the body must have the same velocity. It's a pure translation case. Samani question karo. A slight change in the sum can change the system entirely. If mu is 0, the body will undergo a pure translation. There is no rotation coming into picture. All the points on the body will move with the same velocity. And that is v. It's a pure translation. All the points are having the same velocity. You know that in a pure translation, the bodies of the particles inside the body have the same velocity. That is the case. Yes, all the points move with the same velocity, and so what can I write down the kinetic energy as? Half mv square, the mass is m, it is moving with the velocity v, so the kinetic energy will be half mv square only due to translation, and that is basically brought due to change in potential energy. I can write it as mgh. So m cancels out, I get the velocity as root 2gh. I get the velocity as root 2gh. I get the velocity as root 2gh. This is via energy method. What, can you calculate the same amount via the force method? What is the acceleration of the body? G sin theta. Acceleration of the body down the incline will be g sin theta. mg sin theta के कारण I can say that the acceleration of the disk will be g sin theta down the incline. So the velocity can be written as v square equal to u square plus 2as u0. Acceleration is g sin theta. What is x? S, is it h? It's the length of the hypotenuse. The length of the hypotenuse. H by sin theta. We get the same answer. Sin theta cancels out. I get velocity as root 2gh. The velocity is the same. I can calculate by the energy method, by the force method. I get the same value of velocity when it is translated. Can calculate it when it is rotating. When the body rotates. Rotation plus translation. That is followed by both the methods, energy as well as force.